Good morning, ladies and gentlemen. Today we are going to be talking about 1.4 conclusions and proofs. Yes, we are going to be getting into proofs, what everybody dreads. So I promise they're not that bad. We're going to talk about them today. The first thing we're going to do is talk about the transitive and the symmetric properties. These are two properties that you can use as reasons when you write a proof, because you'll always need to back up your thoughts with reasoning. So the first one is the transitive property. And to use the transitive property, you'll say, if A goes to B, and the goes to symbol I'm using is like a bubble arrow. It's a geometry symbol for means goes to or leads to. So if A leads to B and B leads to C, then A leads to C. So this is pretty much the same thing as the chain rule that you already learned, just with a different name. Transitive property is what we're going to call it when we're doing proofs. It's the more mathematically correct way to call it. So if A leads to B and B leads to C, we can drop that B out of the middle and just say that A leads to C. The other one is the symmetric property. The symmetric property states if A is congruent to B, then B is congruent to A. And that might make a lot of sense. That might seem like something you don't even need to write. But it is important to write it down because we sometimes need to flip around a statement in order to use it in our conclusion proof logic. So in order to flip something around, we will need to have a reason to justify. Why did we flip it around? Why do we know we can flip it around? That is why we use the symmetric property. Coming down here, we are going to draw conclusions. So we're going to state a statement, and we're going to say, what does this statement tell us? What can we conclude from the information we've been given? So this one says that ray BD is the bisector of ABC. Well, if ray BD is the bisector, then one thing I can conclude, because I know what a bisector is, I can conclude that ABD is congruent to DBC, because I know the bisector divides it into two congruent parts. So I'm going to say angle ABD is congruent to angle DBC. All right? We can also go backwards of that idea. Here it says PQ intersects RS. Oops, missed one. XY is congruent to YZ. So if XY is congruent to YZ, I can put the little congruency marks there. And I'm thinking, what can I conclude because of that? Well, if I know that there is two equal parts, then this Y, it must be the midpoint. So that's what I can conclude. I can say, not angle, but point Y is the midpoint of XZ. All right, and that's all there is to it. For this one, there are many possible conclusions. So PQ intersects RS at O. I could conclude that POR and SOQ are vertical angles. That would be a valid conclusion. Angle POR and angle SOQ are vertical angles. There are other things I could claim or conclude. I conclude that POS and ROQ are vertical angles. I could conclude that POS and SOQ are supplementary, or other pairs of supplementary angles that are in here. I could also say I know that POR is congruent to SOQ, but that actually takes two steps of logic. The first step of logic there is saying, well, I know POR and SOQ are vertical angles. And the second step of logic is saying, I know vertical angles are congruent. So if my conclusion was POR is congruent to SOQ, that would actually be a two-step reasoning process, which is fine, but it's interesting to think about the fact that you can break down your reasoning even further than you might already think you can. Coming down here, we are going to talk about proofs. So this is where we get into them. So first of all, we're going to talk about the general format for a two-column proof. And the general format for a two-column proof always looks like this. You will always be given certain information up here, and you will always be asked to prove different information. So we have the starting point of a proof and we have the ending point of the proof, and everything else that we write is going to be in between those 2 points. So if we come down here, we always have 2 columns. There are other kinds of proofs besides 2-column proofs, but we only talk about 2-column proofs in here, so that's the only ones we need to worry about. So in our 2-column proof, we have 1 column of statements and 1 column of reasons every single time. And if you look at the first statement, it is always going to be the same as the given information. So anything we're given, we put down here as statement number 1. And the reason for the first statement is always going to be, it's given. How do I know that? It's given. Then we're going to take this given information and say, because I know this, I can conclude number 2. And then I come over in here and say, why do I know that? And I put my reason. Then I come down to 3 and say, because I know number 2, what can I conclude? And then I conclude it, and I come down with my reason. And then because I know 3, what can I conclude? And eventually, you'll be able to conclude the thing that you want to prove. So whatever it says is prove this thing, we'll be able to conclude that thing. And it'll come down here, and we'll just give one more reason for how we know that's true. Okay? So this is a little bit confusing. They don't always have to be 4 steps. They can be any number of steps. I have some that are 2 steps. We have some that are 9 steps. There are lots of proofs. There are proofs with 50 steps or hundreds of steps, but we're not going to talk about them here. So we've got all of this, and it looks confusing when you don't have math applied to it, but when we do have math applied to it, it can get a little bit easier to understand. So here's a proof that we have the statements for, and we want to just fill out the reasons. So fill in the reasons for the following proofs. So we're given angle A is a right angle. We're given angle C is a right angle, and we want to conclude that angle A is congruent to angle C. Well, angle A is a right angle. That was given information. So we can always say that we've got given information because it was given to us. Angle C is a right angle. That's also given. And then 3, angle A is congruent to angle C. Well, what we're going to ask ourselves is, do we have enough information to prove that? One second here. Do we have enough information to say we know angle A is a right angle, we know angle C is a right angle? Is that enough to say that angle A is congruent to angle C? And in this case, it is. And the reason we are going to write all right angles are congruent. All right angles are congruent. And that might seem really basic. And in fact, it's even more basic than you might guess because it's one of the 5 axioms. Axioms are just big reasons. The 5 axioms of geometry. So this is one of the main sort of pillars of geometry right here. It's really important, but it's not important that you know that it's really important. All you need to know is that all right angles are congruent is a statement that you can use anytime you need it. That's why I put a box around it. Any of these statements that I put a box around, you can use those. If you need a reason, if you're trying to figure out the reason you can say something, use these boxed ideas. They can kind of be your toolkit to say, what's my reason? Oh, maybe this is the reason I need, that all right angles are congruent. Okay? Here's another proof. We've got our given information. We are given that angle RST equals 50 degrees. So I'm going to come down here and say given. We are given that angle TSV is 40 degrees, so that's given. Then we have angle RSV equals 90 degrees. Well, that's not in our given information, but we do know this angle is 50 and this angle is 40. Well then, if this angle is 50 and this angle is 40, I know angle RSV is 90 degrees because I know 50 plus 40 equals 90. And it's okay to say that. I'm allowed to say that as a reason. It's 90 degrees because I know addition. That's fine. Angle RSV is a right angle. Well, I know that angle RSV is a right angle because angle RSV is 90 degrees. And I know that right angles are 90 degrees. How do I write that? All right angles are 90 degrees. I could write that. I could also write the definition of a right angle. Okay? We use definitions an awful lot in proofs, so I'm going to put a box around that one. anytime that you're thinking, how do I know that? Well, I know it because it is. I know it's a right angle because right angles are 90 degrees. You're using the definition of a right angle because you're using basic properties of a right angle to say that it's a right angle. So we'll use the definition. You can use the definition of any vocab word as a reason in your proof. All right, then we come down here. Angle X is a right angle. Well, that was given information. Not all the given information has to be right at the beginning of the proof. If it makes more sense to put it in a different spot, go ahead and put it in a different spot. That's totally okay. And now I see that angle RSV is a right angle and angle X is a right angle. And I have to prove that angle RSV is congruent to angle X. Well, I have two right angles. And I know all right angles are congruent. So all right angles are congruent. See, I'm using that again. I'm using that idea. All right, let's do another one. So, we're given some information. These first two steps are both our given information from up here. So given and given. Let's see, FG is congruent to KJ. I'm going to put congruency markings. It also says GH is congruent to KJ. I don't want to put the same congruency markings again because I don't want to get confused about which pairs are congruent. So instead, I might put a little arrow there. So KJ is congruent to GH. So each pair of these congruency markings shows a pair of congruent segments. Then I need to know that FG is congruent to GH. So if FG is congruent to KJ and KJ is congruent to GH, I can use, from the beginning of our notes today, I can use the transitive property to say that FG is congruent. Oops, I can't say that. I said that over here. Instead, I'm going to write transitive property. So the transitive property is the one that says if one thing is congruent to the second thing, and the second thing is congruent to the third thing, then the first thing is congruent to the third thing. So now I know that FG is congruent to GH. And I have to think, well, how does knowing that FG is congruent to GH help us to know that KG bisects FH? And I'm thinking, well, if some point or if a line splits another line into two pieces, then this line is called the bisector. Where do I know that from? How do I know that? Oh yeah, that's just the definition of what a bisector is. So I'm going to use definition of bisector. And again, you might need to use some of these reasons. I'm going to go put a box around the ones you might use again. So always look back at this note section and see, what could I use as a reason? Do any of these in the boxes fit as a reason that I could use? So use them as a toolbox again for yourself. Coming over here onto the back, we have some proofs and they're not filled out at all. So we're going to need to write some proofs. The very first thing that we do when we write a proof is we're going to make a T-chart. Always. And our T-chart's going to have statements on one side. And it's going to have reasons on the other side. And our first statement is always a copy of the given information. So ray PS bisects angle RPO. And the reason for that is always it's given. It's written down, so it's given. Next, we always say, well, let me look at what I have to prove. I have to prove that angle RPS is congruent to angle OPS. So RPS is congruent to OPS. And I ask myself, do I have enough information to prove it? Does knowing that PS bisects angle RPO give me enough information to prove or to definitely say that angle RPS is congruent to angle OPS? If it does, I can go right there, say angle RPS is congruent to angle OPS. If it doesn't, I need another step. But in this case, it does go right there, because the only thing I need to know that these two are congruent is the fact that it created a bisector, because I know the definition of bisector. And the definition of bisector is a line that creates two congruent angles. So that's the definition of bisector. All right, so that's only a two-step proof. So some of our proofs are not very long. Here is one. We are given that angle TVK is a right angle, and we want to prove that angle 1 is complementary to angle 2. So let's make our T-chart. Statements and reasons. And let's fill in number 1 like we always do. Number 1, angle TVK is a right angle. Number 1 reason is that it's given. But then my proof tells me I want to prove that angle 1 is complementary to angle 2. And when I think about that, I'm like, well, there's nothing given to me that even mentions angle 1 or angle 2. So how am I going to incorporate angle 1 and angle 2 into this proof at all? Well, there's something else that you can do. This is another sort of technique that you can use that I want you to use multiple times if you need it. And that is, I can treat my diagram as if it is information that's being given to me. So like given information. So if I look at my diagram, I can use the idea that angle 1 and angle 2 together make TVK. I can say angle 1 plus angle 2 is equal to angle TVK. So that tells me that this big angle is made up of angle 1 and angle 2. And the reason that I can use for that is just the word diagram. So the word diagram acts a lot like the word given as a reason. It's just saying this is stated, I can see it in my picture, so I know that this is the setup of the problem. I know based on the diagram that angle 1 and angle 2 together make angle TVK. All right? Then we say, well, we're trying to prove that angle 1 is complementary to angle 2. And I know it's a right angle, and I know these two things added together make up the right angle. Is that enough? That seems like enough to me. So I'm going to use angle 1 is complementary to angle 2. And the reason I'm going to give for that, I picked it out because it's two angles that add together to make a right angle. Well, that's the definition of complementary. So my reason is the definition of complementary. And my proof is done, right? And finally, last one here, I have a triangle with some angles going on. So let's make a T-chart with statements and reasons. Well, in here, I have two pieces of given information. So my first two statements are going to be given. So angle A is congruent to angle B. That's given. 2. Angle C is congruent to angle B. That is given. And I need to prove angle A is congruent to angle C. Well, what many of you might think right now is, well, obviously it is congruent because A is congruent to B and C is congruent to B. And so there's a few ways you could write this. You could write, I can prove it right away. I can say angle A is congruent to angle C. And I could say that is because if two angles are congruent to the same angle, then they are congruent. So if two angles are congruent to the same angle, then they are congruent. But that might be a little bit wordy for you. And of course, you can use this as a reason if you want. But if that's too wordy for you, another thing you could do is you could say, well, if it said A is congruent to B and B is congruent to C, then that would be the transitive property, and I could use that. But unfortunately, it doesn't say B is congruent to C. But I can fix that. If I were to use the symmetric property, then my rule 3, or my statement 3, could be B is congruent to C by the symmetric property. And then my statement 4 could be A is congruent to C by the transitive property. So you could have a 4-step proof here if you wanted that. That would be okay as well. A big thing about proofs is just figuring out what would be allowable, because there are multiple ways to write every proof. So if you're making a proof and you're not sure what you're doing is allowed, feel free to ask and I can tell you, yes, you're able to do that, no, you're not able to do that, and eventually you'll build up this sort of rule book in your mind of what you are and aren't able to do, and that's going to help you a lot. All right, so please make sure to ask me if you've got any questions as you do the homework for 1.4. Have a great day, guys.